we will present our topic entitled Determination of Salt Content in Food Products using organometric titration. Salt or sodium chloride is one of the most widely used additive in food products. It's not only enhance flavor but also acts as a preservative and helps improve texture and shelf life. However, excessive consumption of salt can contribute to health issues such as hypertension, cardiovascular disease, and kidney problems. Therefore, it is important to determine the salt content in food products accurately. In this presentation, we will discuss how analytical chemistry is applied in determining salt content using the organometric titration method, including its principle, procedure, calculation, and application in the food industry. What is important of salt analysis? Salt analysis is important for several reasons. Firstly, it helps food manufacturers maintain consistent product quality. Consumers expect the same taste and quality every time they purchase a product. Secondly, salt determination is necessary for accurate nutritional labeling. Food label must provide reliable information regarding sodium content so consumers can make informed dietary choices. Thirdly, food manufacturers must comply with food safety regulations established by government authorities. For this reason, analytical methods for determining salt content are essential in the food industry.
Next, I will talk about introduction to the Moore method. One of the most common methods used to determine salt content is the Moore organometric titration method. Organometric titration is a type of precipitation titration that uses silver nitrate solution as the titrant to determine the concentration of chloride ions in a sample. Since sodium chloride contains chloride ions, the amount of chloride present can be used to calculate the amount of salt in the food product. The Moore method is widely used because it is simple, reliable, cost-effective, and also produce accurate results. Next is principle of the method. The principle of the Moore method is based on the reaction between silver ions and chloride ions. When silver nitrate solution is added to a sample containing chloride ions, a white precipitate of silver chloride is formed. The chemical reaction is Ag plus Cl minus and will produce AgCl. If chloride ions are present in the solution, the silver ions will continue reacting to form silver chloride precipitate. This reaction allows us to determine the amount of chloride ions present in the food sample. Other than that is endpoint detection. To detect the endpoint of the titration, potassium chromate is used as an indicator. After all chloride ions have reacted completely, any additional silver ions react with chromate ions from the indicator to form a reddish-brown precipitate called silver chromate. The reaction is 2Ag plus CrO4 2 minus will produce Ag2CrO4. The appearance of this reddish-brown color indicates that the endpoint has been reached. The volume of silver nitrate used at the endpoint is then recorded for the calculation.
The determination of salt content requires severus and laboratory apparatus. The chemical use includes silver nitrate solution as a titrant, potassium chromate as the indicator, distilled waters, and the food sample being analyzed. The apparatus required include a burette, pipette, conical flask, beaker, analytical balance, and volumetric flask. These materials and apparatus ensure that the titration can be carried out accurately and efficiently. For the procedure, the experimenter begins by weighing a known amount of a food sample. Then, the sample is dissolved in distilled water to extract the salt present in the product. If necessary, the solution is filtered to remove solid particles. Next, we will measure volume of the sample solution to transfer into a conical flask. Then, we will several drops of potassium chromate as indicators are added to the solutions. Silver nitrate solution is then slowly added from the burette while continuously filling the flask. The titration is stopped when a permanent reddish brown color appears, indicating the endpoint. Finally, the volume of silver nitrate used is recorded.
Now, I will explain for the calculation part. To illustrate the calculation, let us consider an example. Suppose a 10 milliliter sample solution requires 15.20 milliliters of 0.100 molar silver nitrate solution to reach the endpoint. Since the reaction between silver ions and chloride ions occurs in 1:1 ratio, the number of moles of silver nitrate used is equal to the number of mole of chloride ions present in the sample. Using this information, the amount of sodium chloride can be calculated. First, we calculate the number of moles of silver nitrate used. Number of mole equals concentrations multiplied by volume. Therefore, number of mole equals to 0.100 multiplied by 0.01520. This gives 0.00125 moles. Since the mole ratio is 1:1, the sample also contains 0.00152 mole of sodium chloride. Next, we calculate the mass of sodium chloride. Mass is equal to number of moles multiplied by molar mass. Therefore, mass is equal to 0.00152 multiplied by 58.44. This gives approximately 0.0888 grams of sodium chloride. The calculated value represents the amount of salt present in the analyzed food sample. This information can be compared with product specifications and nutritional labeling requirements. If the measured salt contents differ significantly from the expected value, corrective action can be taken during manufacturing. Therefore, salt determinations play an important role in the quality control and product standardizations.
Okay, so next I will explain about the industrial application of determination of salt content in food product. Okay, so the determination of salt content is widely used in the food industry to measure and control the amount of salt present in a different food product. So this analysis is commonly performed on potato chips, instant noodle, processed meat, cheese, canned food, and also sauces. So this product require accurate salt measurements to ensure they meet quality standard and consumer expectation. So there are several benefits of determining salt content in food product. So the first one is it helps with quality control. So manufacturers can ensure that every batch of food contains the correct amount of salt, maintaining the desired taste and texture. So the second one is it improves product consistency. By monitoring salt level, and also companies can produce product with the same flavor and quality every time, which increases customer certification. So the last one is it support food safety. So proper salt level can help prevent microbial growth, and also ensure compliance with food safety regulation. So in conclusion, the Mohs titration method is an effective and reliable technique for determining the salt content in our food sample. So during the analysis, silver nitrate reacts with chloride ions present in the sample to form a silver chloride. So the endpoint of the titration is identified by the formation of reddish brown silver chromate Ag2CrO4, indicating that all chloride ions have reacted. So this method is widely used in the food industry because it provides accurate result for monitoring salt level. So therefore, more titration plays an important role in quality food because it can ensuring food safety and also helping manufacturers comply with food standard and regulation.